Good afternoon, everybody. Welcome to class today. Let's get that display capture changed. There we go. Now we're ready to go. Good afternoon, everybody. Welcome to class today. Thank you for joining me, whether you're watching live or you're watching the recording. I appreciate you watching. So today we're talking about conditionals and we're talking about recursion. So what I want to do is I want to run through just a few of our topics and do just a couple really quick examples for you all. I might supplement this as well with another video today. I want to kind of make this one, I think, a bit shorter, though, than I might usually make it. Just hit the high points and then get to writing some code. I think is going to be our plan for today. So last time we spoke, 1 week ago, we were looking at making new methods. And we looked at how with making new methods, we could write our own methods that would be in addition to the main method, which is our primary method. And we were talking about void methods. And we said that void methods allow us to do everything within the method. We can't return anything back out of the method. And so in this module, we're continuing on, and the way that we're going to be able to sort of add to that is with the idea of recursion, which we'll get to by the end of our live session today. But I want to start looking at conditionals. And when we're talking about a conditional basically gives our program the opportunity to make choices. Right? So when we need our programs to be able to make choices, we include a condition or conditionals. And so when we think about a condition is like a mathematical statement. Another term that we might use for what we see in a condition is a proposition, something that can be determined to be either true or false. So these mathematical statements are not ambiguous. They are clear-cut. They return either a true or a false. And we're able to make decisions in our programs accordingly, right? Which is super cool. Basically, if it's true, it runs the code that belongs to that block. And if it is false, then it ignores any code that is in that block. Now, in order to make one of these conditions, we have what we call a relational operator. And relational operators are used to check conditions like whether two values are equal to one another, or whether one value is greater than another or less than another. Right? And these are our mathematical symbols that will help us evaluate our conditions. Right? So when we look at the examples, say, that we're given in the module, or the examples that we're about to look at here in just a few seconds, we see some things that we've probably seen before. Right? Greater than, less than, greater than or equal to, less than or equal to. Right? And as we determine whether or not these conditions are true or false, then it runs associated code accordingly. Now, these are our relational operators in Java. We see double equals. That stands for is equal to, right? And we use double equals instead of one equal because we've already used one equal, right? One equal is for assignment. When I see one equal in a statement in a line of code, that's basically saying that this is equal to that, right? Whereas if I see two equal symbols like we're seeing here, I'm saying, is this equal to that, right? I'm asking a question. So one equals is a statement, two equals is a question. And we're saying, is this equal to that? And so in some programming languages, like for example, JavaScript, we actually see a triple equals or three equals, which not only says, is this equal to that, but is this equal to that and also the same type of data. So we can get really specific with these relational operators. The second one that we have here is exclamation point equal, which is not equal to, right? So if I see an exclamation point, what that essentially means is a not. We also call this a negation, right? If you see an exclamation point, whatever comes after it is the opposite of what it would normally be. Right? So if x is not equal to y, or in some cases, if we are looking at what we call a flag variable, we might see something like not true. Right? So if something is not true, that is false. But where this gets into sort of a gray area is if we say, well, if x is not, if not x, meaning x is not true, and x is false, then that means that statement is true. Right? And what we see here is what we call a flag variable. It's a variable that we set to be either true or false. We'll talk more about them in the future when we get to iteration and we start looking at loops. But basically, bool x is false. But since we're saying not x here, then since x is false, not x would be true, right? So we kind of have to be mindful of what we're looking at here and whether or not it evaluates to true or false. So double equals asks yourself the question, is this equal to that? Exclamation point equals, or also called bang equals in programming, stands for, is this not equal to that? Greater than symbol is this greater than that? Less than symbol is this less than that? And then we have greater than or equal to and less than or equal to. Right? All of these giving us some good data. Now, there is one special case, right, where we don't use equals equals, and that's if we have strings. And so we'll do an example of that with strings in just a few moments. For the time being, let us go to a Replit here and do a few little examples. Right, so I'm going to write myself a function here, and we're going to call it condition test, or just condition example. Right, so I'm going to write a public static void condition examples function or method. Right, we talked about last week how one of the things we can see is that in Java, Functions are called methods, but in other programming languages, we might call them functions, right? They're just different names for essentially the same thing. And I'm going to write my if statement. And I'm going to say something like, if x is greater than 7. And in this case, right, since x doesn't exist yet, we need to make x exist. That's why I got a little bit of a red squiggle there under x. So what I might want to do is I might want to bring this in as a parameter. So in our parentheses here, we can bring in an int x parameter. And now we're making a comparison, right? And so we see if x is greater than 7, x being some number that we don't know yet, 7 being 7, we can start to run some code from there, right? And so from there, I can put curly braces, and that set of curly braces defines my block. So what I put between these curly braces here and here go with that if statement. So the code that I put in between these two sets of curly braces, they're only going to execute in the event that this statement, if x is greater than 7, is true. Right? So if x is greater than 7 is true, we are going to system.out.println x is greater. Right? Something like that. And so if we do some examples with this, we can start to see how it might function, right? Like if for example, we were to import scanner. So we will import java.util.scanner. And in our main function here, we will create a new scanner object. So we'll say something like scanner in equals new scanner on system.in. We will ask our user, say system.out.print, enter a number. And then we will take the next integer and pass it through to a variable. Let's say we'll call it int user input equals in.next int. Right, so now from there we can just take our user input value, pass it into the condition examples function as a parameter, and see what we get. Right, so condition, we'll invoke our condition examples function, and we will pass it the value of user input. Now, as we run this, it'll give us the ability to enter a number here. And if we enter a number that is greater than 7, we get the code returned to us that x is greater than 7. If we enter in something that is not greater than 7, if, for example, we enter in something that is less than 7, like 6, we will get absolutely nothing, right? Because that condition we made on line 12 there is not true. So if the condition that we made on line 12 is not true, then that means that the code that we put in between that block for that function or for that method is not going to execute. Right, now, another thing that we could do here, though, is we can add an else statement with this. Right, so an else statement allows us to look at all other cases. So if x is greater than 7 is true, then that means that x is some numerical value from 8 to infinity. So it's very broad in terms of what x could be. With our else statement here, basically what we're saying is anything else, right? So if our if statement here comes back false, then our else statement will trigger true because it's anything else. So if we were to enter in a system.out.println line here, and we could say x is lesser, then we could see the results of this, right? So now what we can see here is if we run this, we'll first start out by trying to enter a number. I'm going to enter a number 8, which gives me x is greater. And then I will follow up by running the program again and enter a 6, and it will tell me that x is lesser. Now that's all well and good, right? But there is a condition here that we did not account for. And that is if x is 7. So if x is 7, in that case, x is not greater than 7, but it's also not less than 7. It is equal to 7, right? Which is an entirely different comparison than what we've been making so far. Right? When we're making the comparison that x is greater than 7, the else by default, by what we've determined here by the item that we're printing to our console, is that x is somehow lesser. But what if it's not? Right? In these cases, we might want to use an else if statement. So in between the if and the else, and this is the order that you have to put them in, I can put an else if. And else if also gets a condition. So in this case, I could say else if x equals 7. And then it's going to go down the line accordingly. So if x is greater than 7, it's going to trigger that if statement, and it's going to run that code. Else if x equals 7, it's going to trigger this block, right? Which is going to be our system.out.println x is 7. Otherwise, it's going to trigger the else statement. If it's anything else, if it is not 7 or it is not greater than 7, then presumably based upon what's left is it's got to be less than 7. So we're going to trigger that else statement and we're going to say x is lesser. This is what we call a chained condition, right? Having an if, an else if, and an else. In a chained condition, I can chain as many else if statements as I want to test as many values as I might want to test, which can be pretty useful to us if we were of the mind to do so. But we can also do some things more efficiently by, say, iterating a counting variable, which is something that we'll do later on in the semester. But the more else ifs we have, and we can have as many as we want, the longer the chain gets. And so the more operations our computer is going to have to do in executing the program. It's always going to start at the if statement, proceed through any else if statements from top to bottom, and then if none of the previous statements trigger, it's going to trigger the else statement. Remember that the first statement that triggers true will be the one that gets the output. And it will stop there. It will not proceed. Right? So if x is greater than 7, it's going to trigger that x is greater than 7. But even if I were to have a number that were greater than 7, say if I were to add another condition here that said something along the lines of else if x is equals 10, print system.out.println x is 10. In this case, x is 10 will never be reached. Because of the way this goes, right? Since 10 is greater than 7, what's going to happen is it's going to see that x is greater than 7. Because 10 is greater than 7, it's going to trigger that first statement, and it's going to be done. Right, so we can see that in practice, right? Because that's what we have here. If I take and run this, I get to enter a number. I can enter the number 10. And we see that x is greater, right? Because that is the condition that is evaluated first. 10 is greater than 7. That is true. So we get x is greater. Since that's the condition that runs first, we will never reach the x equals 10 in this bit of code. Right, so you might be wondering, well, how would we fix that? Right, and the way we would fix that is we change the order in which we evaluate our conditions. So we might want to evaluate x to see if it is equal to 10 first. And then we'd say x is 10. And then put the greater than into an else if statement, where we would say that x is greater. Now when we see this, right, if we enter in our number, if we enter in, say, a 10 here, we get that x is 10, right, where we couldn't get that before. And if we enter in any other number that is greater than 7 but not 10, like say 11, we get x is greater. Right, and so these are the basics of how a chained condition works. Another interesting thing that we see in a conditional is called a nested condition. And that's basically where we put a condition inside of a condition. Where it would essentially be saying, if this is true, then check this thing to see if that is true. And we can go as deep as we want with nested conditions as well. You know, just as we can chain as many chained conditions together as we would want, we could nest as many nested conditions as we would want. They just go inside of an existing if statement block. And we could use our else statement accordingly. So I said that there is one example, and that example is strings, that handles things a little bit differently. So when we're talking about relating strings, we don't use double equals to check the value, right? Remember, one of the things that we've talked about before is that strings are not primitives in Java, they are objects, and so they work a little bit differently. So if we're checking a string value, you cannot use a standard mathematical relational operator. You cannot use a standard double equals. You need to use the dot equals function. So we could enter in and we could check, say, a password against a relational string. So let's give that a try. Right, in order to help us do this, I think one of the things that I might want to do is I might want to move our scanner to the class level instead of keeping it inside of the main function. That way we can use it across multiple functions. So I can create a public static scanner in on system.in. And now in order to access that, if we run that, it will still allow us to enter a number since that is static and our function here is static. Right? So I could still enter, say, a 12 and get x is greater. So let's create ourselves another function. I'm going to just comment out a couple lines here. And I'm going to write a function that's going to be called check password. So public static void check password. And let's create ourselves a string variable, which is our secret password. And we'll set it equal to a new string that is a super secret password. Right, so now we have a string that we can check against another string that might be entered in. Right, so let's take and pass a string to a variable using our in.nextLine. Right, so maybe we could add a system.out.print, enter password. Entered pass equals in.nextLine. And we want to make sure that we have our string data type with that as well. And if we were being really cautious about it, we would go ahead and make it an object. So that would be new string in.nextLine. Like so. So now we have an object for our super secret password. So now what we would want to do is we would want to check to see if our secret password is equal to our entered password. So we'd use our conditional statement here. And we said that this won't work, right? If we try to do that, it looks like it's going to work, but it won't work. Right? Because we can't make comparisons of strings like that. So if we called our check password function in our main method, check password. Let's clear out our console here to just make it a little cleaner. And we tried to run this. It's going to tell us to, oops, and I forgot to comment out that incorrect number. So let's stop that, clear our console again, and run this now. So it's going to tell us to enter a password. I'm going to enter super secret password. But it's not going to do anything. Right? This super secret password and what we entered in here is the same, but it's not going to do anything because we used double equals here and it doesn't work like that. Instead, what we use is our dot equals function. So I would say something like if secret password dot equals, and in parentheses, our entered path. So we have to use this entered pass function to compare string. So I can run this. It's going to tell me to enter a password. I can enter super secret password. And now it's going to tell me access granted. And if I wanted to here, I could also include an else statement for system.out.println access denied. So now if I enter in something that is not the super secret password, my access gets denied. Right, and this is basically how this works in the real world, right? Like we see this in relation to passwords and usernames, which is the next thing we're going to add to this. Right, because it is true that sometimes we want to compare more than one item. So let's create another string here. And we'll call this one username. And we'll set that to a new string called secret user. Well, now I want to evaluate if both the username and the password are correct before I let the user have access. Now, one of the things that I could do, right, is I could wrap this whole thing in another if statement, right, and do the whole nested if statements that I talked about earlier. Or I could use what we call a logical operator. And a logical operator is going to allow us to use multiple conditions in a single if statement. So for example, right, if I wanted to add a line to my code here, it said something like system.out.print, enter username, and then we take string entered username and set it equal to a new string of n.next line. Right, so now we have the ability to check to see if we've entered a username properly, right? We could take a username here as well. So what I'd want to do here is I'd want to add a secret username dot equals, or entered username rather, if entered username dot equals entered username dot equals username. And then we add our logical operator here, which is two ampersands and. So if you see two ampersands like this means that and, right? So this part and this part have to be true in order for access to be granted. So now if I run this, it's going to ask me what my username is. Right, so let's try here secret user. Let's first try it to where it works, right? It's going to be secret user and then super secret password. And it's going to give me access granted. But now if one or the other is incorrect, right? For example, instead of entering secret user, I enter secret user 1 and my super secret password. In this case, the password is correct, but not the username. So since both of those items have to be correct, it's going to deny my access. Same thing for if the password is incorrect. If my username was secret user and my password was some other password, my access is denied. So even if one item is true and the other item is false, it is going to deny it because we used and. That means both of them have to be true. Now there are some other logical operators that we see and use that mean different things, right? Like we see that exclamation point for not, right? That's our negation operator again. And we also see bar, and the bar is the key above the enter key on your keyboard, and that stands for or. So if ampersand, or and means that both part A and part B have to be true in order for a conditional to be true, the two bars mean that part A or part B can be true for the condition to be true, right? So for example here, if we look at the last bullet point on this slide, We say x is greater than 0 and x is less than 10. In this case, it is only true if x is something that is both bigger than 0 and smaller than 10, which means that it's going to give you some value between 1 and 9. Which is valuable to us. So since we've already seen some of this information, I'm going to run quickly through a few slides here so that we can get to recursion. So we talk about chaining and nesting, right? And these are just some demonstrations or some visualizations of chaining. So we see chaining here, right? We saw it in our demos. If, else if, and else. They have to be in this order. And I can have as many else ifs as I want. Chains can be as long as you want. You just add more else if statements. All your else if statements go in the middle. Try to keep your chains properly formatted to keep them readable. Right? Because if we're not paying attention to our formatting, one of the things that we can do incredibly quickly is get out of format and end up with something that's challenging to read. In a nested condition, we put a condition inside of a condition. Right? So in the example that you see here is we say if x equals 0. So that in that case, right, there is only one condition under which our program will print out x is 0, and that is if x equals 0. Now we have an else condition here, but inside of that else condition, we have another if and else statement, and this is nested. Right? So in this case, we're checking to see if x is greater than 0, in which case it is positive. Otherwise, it is negative, right? Because we've already checked for 0. So since we've already checked for 0, we've ruled out 0 if we get to the else statement. So that means it must be something between 1 and infinity or -1 and negative infinity. So if it is greater than 0, we know that it is positive. If it is less than 0, we know that it is negative. We can do this as much as we want. Just make sure you chain it, or just make sure that you format it properly. If you have to go more than a couple deep, I would reconsider how you are utilizing your logic. And we also have those flag or Boolean variables that we talked about. And this gives us the ability to have something that starts as a true or a false. It's called a flag because it signals or flags the presence or absence of a condition. And so if we were to look at an example of a flag, we have Boolean variables that are examples of flags. So we have Boolean even flag, which is going to create a true or a false, and Boolean positive flag, which is going to create a true if x is positive. So if I were to use a flag variable in a condition, I can say if even flag. Right, and so this way the condition is being checked not in the if statement, but in the Boolean variable where we did the evaluation from the previous screen. Right, Boolean positive flag if x is greater than 0. So in this example here, we can assume that x has already been evaluated, that it already exists in our program, and that it is some number. And so if x is some number from 1 to infinity, then this statement here would be evaluated as true, and it would put the value true in our positive flag Boolean variable. we see if n modulo 2 equals 0, right? We talked about modulo previously. The modulo problem gives us the modulus, in which case we get the remainder of a division problem. So if some number n that's been previously evaluated, modulo 2 has no remainder, then that means that n is positive, and that this variable would evaluate to true, and it would put a true inside of this variable container. So when we get to here, right, the variable even flag has already been evaluated. So if that Boolean from the previous page was something like int n equals 8, and then Boolean even flag equals n modulo 2 equals 0, well, in that case, this would evaluate to true. And this code would run. Otherwise, if this was something like 7, then this would evaluate to false. And this would not run. Now, the only case in which that would not happen is if we had a little bit of a modification here. Right? As if I added an exclamation point right here. Right here. Because in that case, it's become not even flag. In which case, it inverts the logic. So now, instead of looking to see if n modulo 2 equals 0, and that returning true, if we get false, meaning n modulo 2 is something other than 0, it gets flipped because of the presence of that exclamation point. So anything that previously resolved to true becomes false, right? It gets flipped around. And anything that would previously resolve to false gets flipped around and becomes true. Now, with that being said, I want us to take a little bit of time here and talk about recursion. I think recursion is a pretty important concept for us. In fact, I want to check something really quickly here before I do that. So just bear with me for just 1 second. Yep, I want to talk about recursion really quickly here today. So let's talk about what recursion is, and then let's do a little bit of an example. So when we're talking about recursion is the first opportunity that we have to do a process over and over and over and over again. There are 2 different ways that we can duplicate or repeat actions in programming. One of them is recursion. The other one is iteration. Anything that we do recursively can also be done iteratively and vice versa. There are some instances where it is more efficient to do one or the other. So what exactly is recursion? Well, problems in every area of life basically can be defined recursively, which means that they can be defined in terms of themselves, right? So if we look at the definition of, say, a compound sentence, well, that's described as 2 sentences with the word and in between them, right? So a compound sentence being 2 sentences, you're using the word sentence to define what a sentence is, which is recursive. Right, we can also think about it like 2 mirrors facing one another and reflecting off of one another. Right, one mirror is reflecting another mirror, which is reflecting itself back to the first mirror, and it's just going on into infinity. So recursion in programming is when a method invokes itself, right? There are 3 laws of recursion, which are on the next slide, so we'll hold that for just a second. But one of the things that we've noticed, right, is that as we are looking at a method, right, we create a new method, and then we invoke that method somewhere. Right, and what we said previously was that if we invoke a method, We could invoke it anywhere in the main method or in another method, and when the flow of execution hits that invocation, it's going to execute that method. So if I put a reference to a method inside of that same method, for example, if I had a method called public static void factorial, and then inside of there put a reference to factorial, I'm calling that method from within itself, which means it's just going to loop and restart itself forever and ever and ever and ever and ever. Right? We don't want to do that. Right? We want to make sure that we're following the 3 laws of recursion. So what are the 3 laws of recursion? One is that there must be a base case. Our base case is a path through which the code goes that does not call the function again. Well, we just learned about a method that we can utilize where a statement only runs if a certain thing is true, right? It's our conditional statement. So we can have a condition with a base case. There must be also a recursive case, which is what we just saw, a line of code that calls the function from within the function, and the ability to move that function or move that problem toward the base case. Now we do have to make sure that we resolve this at some point to where the condition no longer returns true, right? Because we can't just run our program forever. This is called an infinite loop, and that is bad, right? Because eventually it's going to just crash our program. So let's just kind of break this down into an example. I'd like to write a little program here that displays the results of a factorial. And if you don't know what a factorial is, in certain instances in math, you might see something represented as, say, number, exclamation point. Right? And that stands for number factorial, or in this case, 5 factorial. And what that stands for is 5 times 4 times 3 times 2 times 1. And so this is my base case, right? Whatever this number here is my upper limit. Whenever I get down to here, this is my lower limit. So I can say something like, we're going to bring in some variable here. Let's say it's going to be integer I as an argument. And we're going to say if I is greater than or equal to 1. If I is greater than or equal to 1, all we are going to do is we're going to take the value I and multiply it by the next value, which would be I minus 1. So I would put some sort of function call in here for factorial. So I'd want to set some variable, right? So I would set some variable to be I times factorial I minus 1. And there's my recursive call. Yeah, and actually I can't do that. Oh, I'm trying to freestyle a little bit here. It's causing me a little bit of trouble because I want to print instead of do returns. It's a lot easier to do returns if I'm doing this. Let me think about it here. I think what I want to do instead is invert my logic. So we would say if I is 0, yeah. Then I want to system.out.println 1. Else, I want to run my recursive case, which is just factorial I minus 1. And then finally system.out.println I. Yeah, that's what I want instead. Right, so now I'm starting out with some value. It's coming in here as I. If it's 0, we're just going to enter in, we're just going to get back 1. If it's anything else, we're going to restart the value with I minus 1. Now what that's going to do is that's going to bubble. Right, and we're going to see that happen as we enter in our number. So if we go ahead and call our function here, factorial, and put a value in there like, say, 5, and we run that, we see our values sort of go up. Right, so what's going to help us here is and we see our values sort of go up, and that's because it's bubbling upward. Right, so it's going all the way through these factorials here, I minus 1. So I minus 1 actually gets us 4. The first time through gets us 5. The second time through gets us 4. The third time through gets 3, 2, 1, and then 1. But what we want instead is we want to kind of have something that goes along with us to help us count the previous value. So in which case, what we might want would be something like another value like, say, int n. And this will help us to kind of keep track of that value. So in which case, what I might want here is to say that I subtracts, but n is multiplied. So we'd say something like n, or I, n times I minus 1. Or no, n times I. N times I is what I want. Because first time through it's going to be 5, second time through it's going to be 4, 3, 2, 1. So then what I want to do here is instead of printing that there, I will print n right here. So only when I becomes 0 will I print n. And otherwise, I am going to decrease the value of I and multiply n by I. So what I want to do here is make I 1. So the first time through, n is 5, I is 1. 5 times 1 is 5. The second time through, we're going to subtract 1 from I, which turns that to 4. But now n is 5, so we do 4 times 5. And we just keep going, right? So what we should expect here, if we did this correctly, would be to see 120. And so if we Googled the answer of, say, 5 factorial, right? I'll just Google 5 exclamation point here. We get 120. That's our output of this factorial. Right? Because every time it gets to here, it's rerunning, it's jumping back up to here, rerunning this function. The value of I is decreasing, so eventually it gets to 0. The value of n is being multiplied by the previous number. And so we could even go so far as to take an input for this. Right? And we could just, and for the sake of time here, I will just put a value called like int input number. And we'll set it equal to n.next int. And so now instead of 5 here, we just put input number. 1 remains constant. So if I were to run this from here, it's going to force me to input a number, like say 3. 3 times 2 is 6, times 1 is still 6, so we get 6 on the output. And so I could do something even bigger, like I could do, say, 20. And that's going to be 20 times 19 times 18 times 17, so we're going to get a pretty big number here. Right, we actually get negative 20,000. I think that's because we should be using 20 factorial. It's so big that we've gotten into a bad spot here, right? Because that's like 2.4 times 10 to the 18th. So we probably want to test that with a bit of a smaller number, like say 8, 40,320. Right? Because we get to some big numbers pretty quickly when we're calculating factorials. Right? But if we Google the answer to 8 factorial, we see that it is what we got from our problem. So we were able to recurse over our method, run that method multiple times, changing the value of I each time by doing decrementation here, and taking another value and multiplying it by I to get our factorial. And so that is a lot of stuff. I probably will give you all another video to try to help support you a little bit more with recursion. But this is where we'll stop for today. So that's all that I have for you for today. Thank you for watching. We'll see you next time. If you're watching this and you have any questions, please let me know.